Gather round while I show you the steps for a one-way ANOVA and how to make corrections for multiple tests. So, in this data set, we have conditions, and if you click on this button up here, it goes from the dummy coding to the label. This is a study looking at how playing Tetris can decrease unwanted imagery, such as that seen with PTSD. Obviously, these folks did not have PTSD inflicted on them, so this was looking at an upsetting video, not a traumatic event. So we've got 4 randomly assigned groups. We have no task control, reactivation plus Tetris, Tetris only, and reactivation only. Reactivation being that they were shown images that were from the film to bring the memories to mind. This is part of what's known as exposure therapy. Trauma psychologists, please correct me if I'm wrong. And then Tetris is a fun game that I just found out is back on the App Store. So it was installed on my iPhone, where you move blocks around and try to get them to clear out before your screen fills. Anyway, first step is go to Analyze, Compare Means and Proportions, One-Way ANOVA. Our factor, that's the same as our condition or whatever groups we're looking at. Factor is just stat speaks for groups. We're going to click that here. Unlike a t-test, we could test a whole bunch of dependent variables, but we're not going to do that. Instead, what we are going to look at is days 1 through 7 number of image-based memories. So if we just click OK, all we get is the omnibus F and the p-value, as well as the degrees of freedom. We don't know the means, we don't know the variability, we don't know the range, we have no idea where this effect is. All this is telling us with the omnibus F effect is somewhere in there is at least one mean that's different from the others. We do know that degrees of freedom for groups, DF1 would be 3, because 4 groups minus 1 is 3. And in degrees of freedom participants, DF2 is 68, because when we subtract the number of groups from 68, we have 72 participants. We get 68 degrees of freedom. Now, let's do this again, but let's get some more helpful information. So first, we're going to go to Options and click Descriptive Statistics, click Continue, get OK. Now we got a little more going on. We can at least look at these means and eyeball them and say, hey, it looks like this control is pretty big, this reactivation plus Tetris is a lot smaller, and these are more in the middle. So we also have our standard deviation, standard error, so we can have some idea of variability. But we don't know if the differences among these conditions, when we do pairwise, comparing one condition to another, if we know if they're significant. So what we're going to do is go to Analyze, Compare Means and Proportions, One-Way ANOVA, and now we're going to do post hoc, and that is for post hoc testing. It is one of the times in SPSS where the button is exactly what you want. Post hoc testing is from the Latin after this, and that means once you get a significant F test, which we have here, after this, you can test to see if there's differences in the means. Now, there's lots of different ways for comparison. LSD is the most liberal. There's no correction. Von Ferroni is the most conservative. You're the least likely to detect a significant effect. And the type 1 error rate goes up there. So LSD, the type 1 error rate goes up, Von Ferroni, the type 1 error rate goes down. Correction, I misspoke. Von Ferroni, type 1 error rate goes down. Type 2 error rate goes up. The false negative. So what I like for a happy middle is Tukey. That just seems to be the psychologist's correction of choice. Click Continue and then click OK. And now we still have our descriptives. We have our omnibus F, And now we have multiple comparisons. And what we can see here is each of the conditions compared to each of the conditions. So there's a lot of repetitive testing in here. Every comparison is reported twice. With 4 conditions, there's a possible 6 pairwise comparisons. As you can see, there are 12 comparisons reported here. So each one is reported twice for organizational purposes. So we already saw that reactivation plus tetras definitely seemed to be the lowest. And looking at this, we can see that it is significantly different than the control, which is not surprising looking at that big difference in the means there, but it is also significantly different than reactivation only. Now let's just give this a whirl and look at how the p-value changes when we use a different correction. We're going to turn off Tukey and turn on Bonferroni and take a risk of type 2 error. Continue. Okay. And now we'll see that those two are still significant, but now the p-value has increased, so they are less significant than they were before. And that shows how Bonferroni has more correction for p-values with multiple testing. Now, let's look at LSD, the most liberal option where we really risk type 1 errors. And now you can see that the significance is much greater. The p-values are much smaller. So this is 0.003 for reactivation rate plus no control. And then here it's 0.20 for Bonferroni. And then back up here with Tukey, it's 0.17. So see what I mean about Tukey providing a happy medium. Now, this did not become significant, but it would be what some folks would call marginally significant, approaching significant. In the nearing significance, there's a lot of different terms for it when we're wishful that an effect we see would be significant. Now that 0.063 here, it's 0.379. There, that is not near, that is not approaching, that is not marginal. And then with Tukey, it's 0.242. So you can really see how having those corrections made a difference with the p-values. All right, let's graph these. Let's go to graphs, and then we'll go to bar graphs. We want simple. We're looking at different conditions. This is a between subjects design, so we want summaries for groups of cases. If we were comparing the same people on different measures, then we would want separate variables. Define. Click on mean. For condition, that is our category axis. This is our x-axis, and then our variable is days 1 through 7. I am going to always argue we should have error bars in all things, and I am a one standard error kind of girl. So display error bars, one standard error, okay. And there you got it. And you can tell by looking that there's definitely no overlap between no test control and reactivation tetras. There is, perhaps it's getting in the vicinity of an overlap here. If these were the only two conditions, they might be significant, but they aren't, so they're not, because we have to consider multiple corrections. And then reactivation only and reactivation plus tetras, you can see that there is a significant difference. Those error bars do not overlap. All right, I hope you enjoyed, and follow me for more SPSS.